In this next video, we're going to continue our conversation around costs. We're going to look at a few kinds of costs. We're going to talk about explicit, implicit, and economic costs, and then we're going to turn our attention to what costs look like in the long run. When we talk about economic costs, it includes all the costs that we've talked about before. The costs that are fixed, the costs that are variable, the ingredient costs, the machinery. But there's also another form of cost that we have yet to discuss, and this is our opportunity cost. So this is the lost benefit of doing one thing instead of another. We often associate this with an entrepreneur. If I choose to do one business, I'm not then involved in another business. Or if I choose to open my business, then I can't receive the salary of being an employee at some other business. So all the costs that we've referred to up until now essentially are explicit costs. It's the costs that we pay for our fixed costs, regardless of our output, so our rent and our interest on any loans that we've taken out, our depreciation on our equipment, as well as the variable costs that are like the ingredients, the sauce, the cheese, the wheat for our dough to make pizzas. The new cost that we're referring to is our implicit cost, which is the sacrifice of income that would have been earned by a self-owned resource if it had been employed in its own best use. So when we use that phrase sacrifice, we're referring to an opportunity cost, which is our alternative use of our resource. Now, implicit cost can also include the opportunity cost for anything that we own outright. Let's say we're not just talking about entrepreneurship, we're talking about the building that your company owns. So if you are going to occupy that building yourself with your own business, then you're not renting it out to anybody else, and that is potential lost income as a result of your first choice use. Our explicit costs also do have opportunity costs, but it's just that the opportunity cost is equal to whatever sum that you're paying, whatever amount of money you're paying to acquire the sauce, the cheese, and the wheat dough. It's the money itself that you're giving up to acquire the ingredient is the opportunity cost. Whereas with the implicit costs, it's the lost benefit of doing something else with a resource that you already own. So here we can see an example from Art Tregieki's book. We have our implicit costs, which all add up to £109,000, and explicit costs, and it breaks it down as to what each of those things are, that add up to £50,000. So if we want to find the total economic costs together, we'd add our implicit costs to our explicit costs. This would give us a total economic cost of £159,000. Now we're going to turn our attention to long-run costs. We're going to look at how, in the long run, all of our inputs essentially become variable. So when we talk about our production in the long run, we want to know what happens when the firm changes all of its inputs, essentially, at once. We have enough time now that instead of just increasing the amount of ingredients we use, I can continue to increase the amount of ingredients I use and buy additional factory space, additional pizza ovens. I can continue to expand the scope, or what we'll call in economics, the scale, the size of our business. So our focus in the long run is going to be this phrase, returns to scale. How much extra output do we get as our firm increases its size? And by increasing its size, we mean it's buying up new factories, new land. It's spreading out and becoming larger as a business. This is something that was only made possible in the long run. With regards to our long-run costs, we will refer to three key events in the long run, which we'll define out now. Those are our increasing returns to scale, constant returns to scale, and decreasing returns to scale. So if I'm referring to my increasing returns to scale, it means that if I am doubling the inputs, the ingredients that I'm putting into the production process, and this can include factories as well, then my output is going to more than double. My output increases more than in proportion to the increase of all of my inputs. Remember, there are no more fixed inputs. Everything has become variable. My constant returns to scale suggests that output increases in the same proportion as all of my inputs. So this might be in terms of value. I pay X amount more in order to produce my sneakers, and I get X amount of value of sneakers back out from this production process. For my decreasing returns to scale, it means that output increases less than in proportion to the increase in all of my inputs. Given any percentage increase in all my inputs, my output is increasing by a smaller percentage. I'm essentially becoming less efficient as my firm becomes larger and larger and larger. Now, it's an important key point to distinguish our increasing and decreasing returns to scale from the law that we learned that applies in the short run. With our law of diminishing returns, this is a short run concept. It's showing what happens to output as we increase a variable input, and we're adding that variable input to some fixed input. Remember, in the long run, nothing is fixed. We're actually increasing all of our inputs when we're talking about our decreasing returns to scale or our increasing returns to scale. Let's take a look now at our long run average total cost curve. Our long run average total cost curve is actually made up of a series of changed short run average total cost curves. So it's kind of like the zoomed out version of looking at our average total costs. What we're going to find is that each of these short run average total cost curves essentially represents some fixed input. So my first short run average total cost curve, number 1 here, represents like my first factory, and I can have a bunch of variable inputs added along this short run average total cost curve within one factory, and I'm expecting to increase my output the more variable inputs I combine with the fixed input of the factory. Now if I add another factory, notice how much more potential I have to increase my output. And again, I'd add variable inputs to this fixed input along SRATC2. I add another factory, you can call it factory 3, and another factory 4, another factory 5. All of this occurs in the long run. It's made possible by having a longer horizon of time. So my goal as a firm is twofold. I want to be able to produce the amount of output that I think is best for my business. I also want to be able to do that at like my lowest possible cost. So what you can see is with SRATC1 and SRATC2, they overlap to some extent. And on either curve, I have the ability to produce Q2 output. But if I introduce the second factory, I can produce Q2 of output at the lowest possible average cost. And so I'm gaining some amount of efficiency by building the second factory. And this would be an increasing return to scale. So let's take a look at the long run average total cost curve without the smaller short run average total cost curves. We can see we're using the same axes here. We have costs and we have output Q. And what we're going to see is that this LRATC curve is what we call an envelope curve. Inside of there are all of our production possibilities in terms of our variable inputs. And in the long run, we now know that variable inputs include things like factories. So I'd have an SRATC here, an SRATC here, an SRATC here. But we just want to simplify by looking now only at the long run average total cost curve. So what we can see is it's bowl-shaped or U-shaped, and we can move down and along the LRATC. And as we do so, until we get to the minimum, we are achieving economies of scale. We're becoming more efficient by increasing our output. And with that output, also we are building new factory spaces or buying large and heavy machinery, things that make us more efficient. Then, as we move to the right side of the dashed line, we actually achieve diseconomies of scale. We're getting less efficient, or we're just too big for our own good. And we'll talk in a little while about what those reasons are for what cause a firm to become too big. An important thing to point out is that with this long run average total cost curve, when it's downward sloping, there is always going to be a larger firm size that can achieve lower average cost. There's going to be some greater scale that allows each unit of output to be produced at a lower cost. I should be adding factories if I'm trying to push for the lowest cost relative to the output that I am desiring. Definitionally, the long run average total cost curve shows the lowest possible average cost that can be attained by a firm for any level of output when all of the firm's inputs are variable. We can see, if we look close to this diagram on the left, if we zoom in here, that what is occurring is that all of these short run average total cost curves are tangent to the LRATC curve. It is tangent to each of the many SRATC curves. They're inside of, it's an envelope. And that all of these curves are U-shaped, that these average cost curves have a U shape. So then two more key terms that we'll define are economies of scale, and these are decreases in the average cost of production over the long run as a firm increases all of its inputs. In other words, the cost per unit of output are decreasing. whereby diseconomies of scale are increases in the average cost of production as a firm increases its output by increasing all of its inputs. So costs per unit of output are rising on the right-hand portion of a long-run average total cost curve. So why? Let's answer the question of why do we achieve economies of scale? Economies of scale are related to things like specialization of labor, so that we give each person a particular task. They don't have to be a jack of all trades, and they become better and better at that one thing that we're asking them to do. We think about workers on an assembly line. One person might be screwing a bolt, another person is doing some kind of quality control, another person removes it from the conveyor belt. They can do all of these things more quickly and more productively if they are specialized. Another reason for our economies of scale are the efficiency of capital equipment, particularly as we add larger and larger machines into our production process. We might be adding machines that we simply couldn't use in a smaller shop. So we have a pizza oven with like conveyor belts in it that wouldn't make sense with a smaller business. But now the larger we get and larger a factory becomes, the more space we have to use fancier equipment that is more efficient. We also introduced the idea of mass production, that we have assembly lines that allow us to produce our output in a faster way or with better quality control, with more efficiencies guaranteed by the process. Another thing is that we're spreading these costs over larger volumes. So we might have a cost like marketing where we might produce 100 units of output and use the same marketing budget versus 1,000 units of output with the same marketing budget. Now we're spreading the marketing across more and more units of what we are producing. This applies for our design process. This can apply for our research and development, where we maybe only do it once and then our output can be almost infinite from there. For our diseconomies of scale, we relate it to organizational difficulties, so disputes that might arise across management layers. We're becoming too big, too bureaucratic. There might be issues of communication, especially as we have international offices and we have to coordinate across time zones. We have poor worker motivation, that they might be lost within the institution or not recognized by their bosses. And so these three things could show that a firm is simply becoming too big at this point. So here's the last diagram that we'll take a look at within this video. In this diagram, we see a long-run average total cost curve, but we actually see a sort of flat portion. So it's U-shaped, but it has a flat bottom, kind of like a pot that we'd put on the stove. We don't want it rocking around. It's going to be flat. It stays level. So we have the downward sloping portion of our long-run average total cost curve. And it slopes down until we hit what's called the minimum efficient scale. And this is the lowest level of output at which the lowest long-run average costs are achieved. And from there, we're essentially flat. For the entire flat portion, we consider this to be our constant returns to scale. And what we find when we have constant returns to scale is that our average costs are unchanged. So each unit of output within this section of our long-run average total cost curve has the same average cost. Output continues to increase, but the average remains the same. Let's leave on one last note. So let's remember to distinguish between what we're calling now economies of scale, or increasing returns to scale and decreasing returns to scale, with our law of diminishing returns. Remember that the law of diminishing returns occurs in the short run. So as we see on the short run average total cost curve, we're adding more of a variable input to a fixed input. And so when we do that, we might get sort of a crowding out within our pizza shop of too many workers with nothing to do, and therefore eventually they become less productive. When we're talking about our long-run average total cost, we're talking about efficiency. So when we have economies of scale, we're gaining efficiency, right, to that point of our minimum efficient scale. And so we're actually able to reduce our average costs as we become larger, which includes things like buying new factories, which are now variable to us, such that our short-run average total cost curve could be a representation of each of those fixed inputs now becoming variable: factory 1, factory 2, factory 3, and 4.